Okay, this is the introduction for lab number 12. It's the lab on torque, so in angular momentum. Some things that we kind of know is we know a torque is going to be a force applied at some distance, and that's how we go ahead and that's how we change something's angular velocity. So torque is a force multiplied by a distance, and in order to get something spinning, you have to apply a torque. Once you get it spinning and you stop applying that torque, and it's just going to keep on doing what it's doing. So the first thing I have you do is go to this simulation right here, and you're just going to grab hold of the wheel and get it spinning, and think about what you did and how you did it, and then you're going to let go of the wheel and pay attention to the bug's velocity, acceleration, and angular speed or angular velocity, and then you're going to stop the wheel. So let's go ahead and pop the simulation up really quickly. So here's the wheel, and to get it spinning you just kind of grab it and kind of shake it around like that, and then you can stop the wheel using the brake just right over here. Then we're going to click on the tab that says torque, and we're going to set a force, and we're going to apply that force at a couple different places. We're going to first set the radius equal to 0, and then we're going to set the radius equal to 4, and kind of pay attention to the torque on the ladybug and her velocity and acceleration. And then we're going to brake the wheel. And so let's go ahead and take a look at that tab really quickly. We're going to click on torque, and you can just type in a number right over here to apply some force, or you can use the slider, and you can kind of see that you can mess around with the radius as well, either using the slider or entering it. And this is going to be the calculated torque, which is again just going to be a force at a distance. Then you can click go and make your observations, and you can even rewind and everything like that. Then what we're going to do is we're going to come and take a look at angular momentum. Remember that angular momentum, like linear momentum, is a conserved quantity in the absence of external torques. So I'm going to have you get the wheel spinning, and I'm going to have you set the mass of the disk. Now, what is the rotational mass or the moment of inertia of the disk? The lab actually tells you exactly what that is, but if you really wanted to do it on your own, it would actually be equal to 1/2 the mass of the disk and the radius of the disk squared. And then I say, what is the angular momentum of the system? One thing to kind of keep in mind is when you look at the lab, that's going to be given by the symbol, L is equal to question mark, and it'll be on the graph. And I'll show you where these guys are in a little bit. Then I have you increase the mass of the platform, and kind of what you're doing is you're messing around with the mass of the disk, and the rotational mass is going to change correspondingly. Now, some things that we know is if we initially had some angular momentum, which is angular speed times rotational mass, that in the absence of external torques, that has to be equal to a constant. And what we're doing is we're kind of messing around with the rotational mass when we do right here. And so what has to happen is the angular speed has to change correspondingly. At the end of the day, the angular momentum, the product of these two, has got to be equal to a constant. So all I have you do is keep on increasing the platform mass until you've reached something, and you just be recording these guys right over there. And let's go ahead and pop over to the simulation really quick. So here we are at the angular momentum. We can give this thing some speed. I tell you to set it to 45. And we can mess around with the mass of the platform kind of right here. And as you'd expect, as I mess around with the platform mass, my angular speed is going to go up and down. The rotational mass, you can read that off right here. And you can read off the rotational mass you can read off right here, and the angular momentum you can read off right here.